What's up everybody, and welcome to my little video series called What is Machine Learning? My goal for this series is that really anybody can understand what machine learning is and how it generally works. And this means that there's absolutely no prior knowledge required. So let's get started. What is machine learning? Well, as the name suggests, machine learning is about machines that learn. And I think if you rephrase it that way, then some obvious questions arise, namely, okay, how do they learn and what do they learn? And those are two questions I'm trying to answer in this video, at least at a very high level. And since it is much easier to understand abstract concepts like machine learning with an example, I'm going to answer those two questions by falling back on the often used and well-known iris flower dataset. In fact, it is so well known that it even has its own Wikipedia article. But instead of just relying on this dataset alone to explain how machine learning works, I'm going to give it some context by introducing a made-up scenario. And that way I hope one can get also some understanding how machine learning could be applied to solve a real-world problem. So what's the scenario? Imagine you're a flower grower and you're specialized in iris flowers. You grow these three different types of flowers, and even though they are different types, they look extremely similar to each other, which means that you have to be a real expert to be able to distinguish them. And if we take a quick look back to the Wikipedia article, we can see that the flowers contained in this dataset indeed look very similar to each other, at least those two, Iris versicolor and Iris virginica. So I think it's not too much of a stretch to say that you have to be a real expert to be able to distinguish them. Okay, back to the scenario. Let's say you have a large field with thousands of these flowers. And let's also say that you can't have separate fields for each type of flower because they don't grow well in monocultures. So they have to be mixed up with each other. And now, when it's time for the harvest, you're bringing some low-level workers and you want them to pick the flowers and you also want them to sort the flowers. But they are obviously no iris flower experts, so you have to train them how to distinguish the different types of flowers before they can start to work. The problem with this approach, however, is that every season there are new workers. So you have to train them anew every single time. And this is just a very repetitive and inefficient way of doing things. So you try to devise a simpler approach for those workers to distinguish the different types of flowers. That's the problem you're trying to solve. How can you get those workers to sort the flowers without having to train them? And since you've heard about that thing called machine learning, you pick 50 flowers of each type yourself and you gather some data on them. And this is the first element to answer the question how machines learn. Namely, they need some data. Just like humans can learn from experiences, machines can learn from data. But data is a relatively ambiguous term, so what does it actually look like in the context of machine learning? Well, in most cases, you can think of data simply as a table. The rows of such a table always represent individual examples or instances of a particular subject of interest. So we are interested in iris flowers, hence each row is one specific flower. And the columns of such a table, they always contain different characteristics or so-called features, which basically describe your subject of interest. So in our scenario, the data that you gathered contains information about the sepal length and width and petal length and width of the flowers. The sepals are those bigger outer leaves and the petals are the smaller inner leaves. And what you did is you simply measured their length and their width and then you recorded those values into the table. And you did that because as the iris flower expert, you suspect that these features are the most useful to distinguish the different types of flowers. And furthermore, as the expert, you were also able to determine what species each particular flower was. And you stored that information into this last column. And this is kind of a special column. It's what's called a label. And going back to our graphic, this is what machines are supposed to learn. So if you have such a label in your dataset like the species column, then a specific type of machine learning is called supervised learning. And this can be further broken down into two subcategories, one of which is classification. And classification simply means that the label can take on only a discrete number of different classes. So in our scenario, for instance, we only have 3 different types of flowers, so the label can take on only 3 different types of classes. And now, here's what supervised learning tries to do. Suppose you go back to your field and you pick a new flower, and it has the following values: a sepal length of 6.9, a sepal width of 3.1, a petal length of 4.9, and a petal width of 1.5. And the question that supervised learning now tries to answer is, what species is this particular flower? And ideally it should say, okay, a flower with these values, that's an iris versicolor. So more generally speaking, the goal of supervised learning is to predict a label of a specific example solely by looking at its features. And the way that it achieves that is with the help of an algorithm. And going back to our graphic, this is the second element, how machines learn. And algorithm might sound very technical or complicated, but it's basically just a number of predefined steps that transform an input into an output. An everyday analogy, for example, would be a cooking recipe. The ingredients are the input, the final dish is the output, and the steps described in the recipe are the actual algorithm. So an algorithm in itself is something relatively trivial, but what makes machine learning algorithms so powerful, at least what I think makes them so powerful, is that they use data as input and they output a decision. And what the broader implications of that might be, I will discuss in the last video of this series. But for now, it's enough to know that we have everything we need to make our machine learn, namely some data, in this case it's label data because we're doing a supervised learning task, and an algorithm. So how does machine learning work, at least at a very high level? Well, you simply show the algorithm some examples and you say, okay, a flower with these values, that's an iris versicolor. A flower with those values, that's also an iris versicolor. And a flower with such values, that's an iris virginica. And you do that for all the examples that you have, and that way the algorithm will learn to detect patterns in this data. And once it is trained, it will be able to predict what species a particular flower is, solely by looking at its sepal length and width and petal length and width. And this is what you as the flower grower wanted to achieve, because now the flower pickers don't have to know anything about iris flowers. All they have to do is to measure their leaves, and then they put in those measurements into the algorithm. And then the algorithm tells them what type of flower they picked. In this way, they can sort the flowers accordingly without having to have any expertise in iris flowers whatsoever, which means that you don't have to train them anymore, which is the goal you wanted to achieve in the first place. So this concludes our scenario, and hopefully it demonstrated how machine learning generally works. And since this video should just provide a high-level overview, in the next video I'm going to talk about one specific machine learning algorithm in detail. And this algorithm is going to be a decision tree. But before I end this video, I want to go back to our graphic and fill in those missing terms. So first, the other type of supervised learning is called regression. And in contrast to classification, you're not trying to predict a certain class out of a number of classes, but instead what you're trying to predict is an exact number. So let's say, for example, that we have a data set that contains information about houses. The features, among others, might be the number of square foot of the living space, the number of square foot of the whole lot, and the number of bedrooms. The label is the actual price of the house. And here again, you show the algorithm a bunch of examples and you say, okay, a house with these values has that price. A house with those values has this price. And this time, once the algorithm is trained, it will be able to predict the exact price of a house solely by looking at its features. And if you are, for example, someone who invests in real estate, then this might be useful if you want to determine how much you should be willing to pay for a specific house, at least based on this analysis. So that's regression. Next, the other type of machine learning is called unsupervised learning. And the difference to supervised learning is that here you don't have a label in your data. So in our iris flower example, there would be no species column. Only the sepal length and width and petal length and width would be left. and how this difference affects the goal of unsupervised learning compared to the goal of supervised learning is probably easiest explained by looking at the following diagrams. So here I depicted two scatter plots with the pattern width on the x-axis and the pattern length on the y-axis. And as you may know, each dot in such a diagram represents one specific instance of your data. So this dot, for example, is a flower with a pattern width of 0.5 and a pattern length of about 1.7. And the data depicted in both diagrams is the same, so all the dots are in exactly the same places. The only difference is that on the left side we have a label. The green dots are Iris setosa flowers, the orange ones Iris versicolor, and the blue ones Iris virginica. So this left scatter plot represents our supervised learning case, and on the right side we have the unsupervised learning scenario, where there are no labels, which is why all the dots have the same color. And what the algorithm now tries to do is to identify groups of flowers that seem to be similar to each other and that might fall into the same class. And as you can see, this cluster of dots is clearly separated from that cluster, so the flowers over here, they seem to have something in common, and therefore they can probably be put into the same category. The algorithm, however, doesn't know what that category actually is. It just knows they belong to a same category. And as we know from the supervised learning case, they indeed belong to the same class, namely, they are all Iris setosa flowers. But what you can also see in this diagram is that there's not a clear separation between the versicolor and virginica flowers. So the algorithm will probably have some difficulty to detect that this cluster contains two classes instead of just one, which is what you might think if you just look at this graph alone. So in conclusion, in the unsupervised learning case, there are no labels, and the algorithm, in a sense, tries to derive those labels from the data itself. And now we can get to the last type of machine learning, and it is called reinforcement learning. And this is somewhat different from the other two types, which is why I depicted it a little bit apart from those two. And without going into much detail, here the algorithm interacts with an environment, and based on its actions, it receives rewards and punishments. And with the help of this feedback, it learns the ideal behavior for that particular environment. So every time you see an algorithm play a game, there's probably some type of reinforcement learning involved. So these are the three different types of machine learning that exist, and the implication of that is that you need different kinds of data and algorithms to solve the respective problems. And this concludes my high-level overview of what machine learning is. And as always said before, in the next video I'm going to talk about decision trees as a specific example for a machine learning algorithm. So thanks for watching, and hopefully I will see you in the next video.